What?
So we are in lesson 4.2, part 3. Now, if you were here yesterday, or if you've done yesterday's notes, we did this chart yesterday, didn't we? Notice it says review. Okay? I'm not reteaching it essentially, but here's the deal. Do you remember how to fill it out?
Yeah. I remember the radians.
Yeah, the radians I remember, but
Okay. And I mean, the idea is without flipping back, you're going to need it memorized eventually. Now, okay, first of all, several of you are saying, okay, you do remember this. 30 degrees, when we convert it to radians, was what? It was pi over 6. 45 degrees, when we converted it to radians, was pi over 4. And 60 degrees, when we converted it to radians, was pi over 3. Those are just equivalents, okay? Multiply by pi over 180 to get there. See yesterday's notes if you don't remember. Now,
Wait, I think I remember now. Maybe.
in order to do sine of 30, if you don't have this chart memorized yet, which I don't expect you haven't memorized yet, what do you have to know?
I think I can remember the triangle.
You have to know the triangles.
Right.
On a 45, 45, 90,
It's 1, 1, and then square root of 2.
okay, your legs are equal, so we use ones to represent them. The hypotenuse is square root of 2 times the length of the legs, so square root of 2 there. On a 30, 60, 90,
It's 1 for the short leg, it's 2 for the hypotenuse, and it's square root of 3 for the long leg.
okay, the short leg is opposite from 30. The hypotenuse is twice the length of the short leg. And the long leg, so opposite 60, is square root of 3 times the length of the short leg. And what's our phrase you need to probably know?
So,
Yeah, we're using SOHCAHTOA. Okay, guys. You know those two triangles. You know SOHCAHTOA. You can do this. What is the sine of 30 degrees?
it would be 1 over 2.
Opposite over hypotenuse? 1 over 2. Okay, this is yesterday, right? I taught this in detail yesterday. What about the cosine of 30?
Square root of 3 over 2.
Adjacent over hypotenuse, square root of 3 over 2. Tangent of 30?
Square root of 3 over 3, or 1 over
Yeah.
square root of 3.
Opposite over adjacent, so it starts off as 1 over square root of 3. I said it's good to know that one, but you also need to know when you rationalize that it's square root of 3 over 3. Because when we multiply top and bottom by square root of 3, it becomes square root of 3 over 3. Okay, 45. Sine of 45. Pick either 45 degree angle, opposite over hypotenuse, we're going to have
1 over square root of 2, which makes square root of 2 over 2.
okay, 1 over square root of 2. Multiply top and bottom by square root of 2. And square root of 2 over 2. An easy thing to start memorizing about your chart. What about the cosine of 45?
It
It ends up being the same as sine of 45, doesn't it? Adjacent over hypotenuse, 1 over the square root of 2, which is square root of 2 over 2. And an easy one to remember, tangent of 45,
1.
1 over 1, which is 1. Okay, 60 degree, back to your 60 degree angle. Sine of 60 degree.
Square root of 3 over 2.
Opposite over hypotenuse, so square root of 3 over 2. Okay, cosine, so SOHCAHTOA, cosine, adjacent over hypotenuse. When we talk about the adjacent side, so rewind here briefly, opposite means the side opposite. Okay, so opposite the 60 was square root of 3. The adjacent side is the side that touches it. That's not the hypotenuse. So adjacent to the 60 is the 1 over the hypotenuse, which is 2. So 1/2. This is the notes from 2 days ago that will, it'll make more sense once you see those. When I reviewed SOHCAHTOA. Okay, and tangent of 60. Opposite over adjacent. So opposite 60 over adjacent. Square root of 3 over 1, which is square root of 3. Okay, guys. This chart really has nothing to do with what we're doing today.
Dude.
It is review. It is purely review. If you haven't done yesterday's lesson yet, it makes maybe a little more sense now, but okay. Keep working, keep learning that chart. Now, are you ready for today's actual lesson? We are solving right triangles, okay? When I talk about solving right triangles, okay, there's 3 here. Given the following right triangles, find the missing sides and angles. Here's the deal. Every triangle has 3 sides and 3 angles. You are to find anything they don't tell you, which usually what that means is you have to find 3 items. Okay? Usually you're going to know 2 angles and you have to find 1 angle. And you know 1 side and you have to find the other 2 sides. Okay? So, as we look at example A, we have a triangle with a 37-degree angle and a side length of A, and then sides labeled A and B. Any thoughts of where to begin to find missing sides and angles?
Which one do we want to start with? The angles or the sides?
Technically, it doesn't matter. Angles are probably easiest.
So angle, you just, 90 and 37, and then so 90 and 37, 127. And then the third angle has to make it 180. So all 3 have 180. So it'd be 53.
Okay. So what's the key point you have to remember? All 3 angles in a triangle always add up to be 180. Okay. So essentially, in order to find our missing angle, we're going to take 180 and somehow or another you're going to subtract the 90 and the 37 from it. Fair enough? Okay. When you do that, what do we get? Try again.
What?
53.
Oh, that's what I meant. That's why I written
You
on that
said it right
paper.
earlier.
Yeah.
Okay.
I was looking at the next problem.
Okay. Now, obviously, Logan said add 90 and 37, subtract from 180. I wrote it as 180 minus 90 minus 37. Same math, right? There's actually a shortcut when it's a right angle. If one angle is 90 degrees, the other 2 angles have to be 90 degrees, don't they? So your other shortcut, if you wanted, would be you could just do 90 minus 37 also. Just a shortcut if you want it. Okay. Now we need to find sides A and B.
So that A is the opposite, so you would set it up. It would be side 37 equals A over 8.
Okay, let's pause. I see some people saying, okay, maybe, and some people saying, what is he talking about? If we start, and you could use we could use either angle, but if we look at 37 here, yes? Okay, so pick an angle we know, which we know all of our angles here. So if we pick 37, and we know 8, what is 8? It is the hypotenuse. Now, if we want to start by finding A, which that would be my preference, A is what to 37? Opposite. So if we're looking for the opposite and we know the hypotenuse, which of our 3 trig functions uses opposite and hypotenuse? And that is, on my other screen, that is sine. Okay, so we can set this up as the sine of 37 degrees is equal to opposite over hypotenuse. So if I have just basically set up the little equation, sine of 37 degrees equals a over 8. Are we okay with that setup now? Now, it's basic math at this level, or pre-calculus basic math. How do you solve that equation for a? If it's a divided by 8, we're going to multiply by 8. So in order to get the answer for a, I'm going to have to do 8 times sine of 37 degrees. And I said you need to have a calculator at your desk, didn't I? This is 100% a calculator homework. You can't do this homework without a calculator. Does your answer match my answer?
Something we learned yesterday is that we have to go back and forth in modes. Your calculator right now is in radians. Okay? And so you'll have to go back and forth. Today will be. So if you arrow down right there, and then if you arrow one to the right, and hit enter, and now you can hit clear, get out of the screen. Notice now you're in degrees. Retype in the same problem, it'll give you my answer.
Everyone else figure out if their calculator didn't give them the right answer, why? Degree mode matters, right? You have to be in degree mode. If you happen to be in radian mode from yesterday, you've got to fix it. My answer key has 2 decimal places on it. So what is this with 2 decimal places?
4.81.
Okay, 4.81. So A is approximately 4.81. Okay. I have found an angle. I have found a side. What else do I need to do? We need to find B. Okay. Options. How would you like to find B?
I just used the same angle and just did cosine instead.
Okay. So if we stick with 37 degrees, B is the adjacent side, isn't it? I'm still going to use my hypotenuse of 8 because that's the nice, neat whole number I know. So if we know adjacent, if we're trying to find adjacent and we know hypotenuse, what trig function connects adjacent and hypotenuse? And that is cosine. So the cosine of 37 degrees is equal to B over 8. Are we okay with that? If it's B divided by 8, to solve for 8, we're going to multiply by 8. So B is going to be whatever 8 times cosine of 37 degrees is. Again, I'm looking for 2 decimal places. What are we getting? 6.39. Okay, guys, you got it? We have all sides and angles identified now. Now, keep in mind a couple of things. First of all, my recommendation, once you know side A is a big, long, messy decimal, yes? I would not use side A to then try and find side B. Go back and use the nice neat whole number of 8 with some, with your B. Okay, so don't try and use your decimals. Now, Logan commented when he set this up that he just kept using 37 degrees. Could we have done something with the 53 degrees if we wanted? Yeah, you could have used 53 degrees if you wanted. That is an option. I tend to just stick with the angle they give me just so, I don't have to worry about any subtracting mistakes, but that is an option. Okay, part B. Let's practice. We have 13 and 57 degrees provided. And technically we have 90 degrees provided. What about our angle? Let's start there. She says it's 33. Do you guys agree with her?
Yeah.
So that could be found by doing 180 minus 90 minus 57. Or just 90 minus 57 if you prefer. Okay, let's find x or y. Thoughts of what you want to set up?
So what I did x first. I did sine 57 equals 13 over x.
Okay, pause that for a moment. Are you guys with that? Which, again, not that you have to use 57. I probably would just because it's the given. You're going to have to use 13, right? So from 57, 13 is opposite it, and x is the hypotenuse. Again, what trig function connects opposite and hypotenuse? Okay, so set that up as the sine of 57 degrees is equal to opposite 13 over a hypotenuse x. Now, how do we solve?
First, so technically you multiply the x across, and then you would divide by sine of 57.
Okay, that's what I would suggest. To get x out of the denominator, I'm going to multiply x over. So it's going to be x times the sine of 57 degrees, and that equals 13. Then, to get x by itself, I need to divide. So I'm going to do 13 divided by sine of 57 degrees. Okay? Not that it's that difficult, but make sure you get it put into the calculator correctly. You could just use a division sign. You don't have to have a fraction bar to get it right here. What are you getting to 2 decimal places?
15.50.
Okay. 15.50, or in other words, 15.5. Okay, we still need to find what? Y. Options to find Y.
I did, because they had given us the 13, I did tangent, and basically the same thing.
Okay. If we stick with the 57-degree angle, 13 is opposite, yes? And we need to find y, which is adjacent. What trig function uses opposite and adjacent? And that trig function is tangent. So an option to set this up is tangent of 57 degrees equals 13 over y. Now, keep in mind, as we set these up, is there just one right way to get these answers? No. So if you play around with something and you get the same answer some other way, I'm not going to argue there's only one right way to do this. Now, what I will say, I do want you using trig functions. No one has thrown it out at me, but I'm not going to be happy if I see Pythagorean theorem. That's not what I'm looking for here. Okay? Not going to argue you couldn't get the right answer, but we're practicing trig functions here. Okay, so to get...
It would be off because you're probably going to round on the sides.
It could be off a little bit.
It could be off.
Yeah. Well, and that's why I say we found x as 15.5. That's a rounded answer. That's why I'm not going to use x to find my y. I'm going to go back and use 13. So, okay, 13 divided by y. So we're multiplying by y. So y times tangent of 57 degrees is equal to 13. To get y by itself, I'm dividing. So 13 divided by tangent of 57 degrees. And y to 2 decimal places is 8.44. Okay. If you have questions as we go about a setup that you would want to try, hit me up. Okay? I'm willing to talk about it. And you guys have been, and this is what I normally do, sticking with the angle they give us. If you want to use the other angle, you could. Obviously, you can't use 90. That's not how this works. We have to use one of the non-90s. Okay, guys, C. What's my missing angle? Okay. 69 degrees here. When you do 180 minus 90 minus 21. Okay. Let's find M or N.
I found M first, and because they gave us adjacent, I used tangent.
Okay.
Nora Young, please report to the high school office. Nora Young, please report to the high school office.
And mainly because it was just easier than having to do multiplying.
Okay. So if we go with the 21 they gave us, yes? Is that what you did? Yeah.
Yeah.
If we go with the 21 they gave us, opposite is M. Adjacent is 14.2. So we're setting up tangent to equal opposite over adjacent. Since it's M divided by 14.2, you're back to just a one-step problem because in order to find M, we're going to multiply 14.2 times tangent of 21 degrees. Two calculator spots. Two decimal spots. 5.45 is what I have written down. You guys are quiet. Minus the Logan. Logan, you've done this in physics this year, haven't you?
Yeah.
That's what I thought. Okay. How do you guys want to find N?
That first name was not 21.
Okay. So if we talk cosine of 21, so cosine is going to be adjacent over hypotenuse. So 14.2 over N. Multiply the N over. N times cosine of 21 is equal to 14.2. And divide. 14.2 divided by cosine of 21 degrees should hopefully provide you a right answer of 15.21.
Yep.
Okay, guys. SOHCAHTOA, know your trig relations, right? Once you know SOHCAHTOA and the trig relations, this is another easy homework, isn't it? Now, you have multiple pieces in homework that are this. You're finding multiple pieces, so notice there's not as many homework problems because you have to find multiple answers on each. Word problem, okay? Trig, in this situation, solving right triangles, lends itself greatly to word problems. Okay, we see this a lot. So, let's look at this example. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. Find the height of the building. Okay, guys, sometimes they give us a picture. They gave us nothing here. I'm going to suggest we draw a picture. But keep in mind what I've taught today, because that's exactly what we're going to be looking for. So, from a point 340 feet away from the base of the Peachtree Center Plaza, we have a building, yes?
Yep.
There is my fancy building. Okay? Huh?
I just do a straight triangle.
Okay. Well, there's my building. And it says from a point 340 feet away. I'll even give you a little stick figure person here. Okay? So here's my building. It says from a point 340 feet away. So 340 feet away is the distance between the person and the base of the building. Okay? The angle of elevation to the top of the building. You guys remember angle of elevation? Angle of elevation, I'm standing here on the horizontal. Angle of elevation is the direction I'm looking up. So that angle of 65 degrees goes between the horizontal and basically like my line of sight, which means right there, that is 65 degrees. Now, the question is to find the height of the building H. So we're trying to find the height of the building H. What did I end up creating in my drawing, of course?
Triangle.
And not just any triangle, but a
Right.
right triangle. Okay. Draw the picture. This is easier than the last problems because I only need one answer. I only need H. How am I going to find H? In other words, look at the angle they gave you. Look at the connection with H and the side they gave you. And set up a trig function.
Put a tangent of 65 equals h over 340.
Tangent of 65, so tangent, opposite, over adjacent. So tangent of 65 degrees equals h over 340. Solve for h. If it's h divided by 340, we're going to multiply by 340. 340 times tangent of 65 degrees, I have two decimal places again, is what?
$729.13.
Okay, 729.13. They gave us our first measurement in feet, so this is feet. Okay. Good news. Your calculator should pretty much get to stick in degrees today, shouldn't it? Okay, it shouldn't have to be bouncing back and forth. Okay, enjoy that when you can. You know, it won't always be that way. So, you have a couple minutes of work time. You can get started. 49 to 58, 61 to 65, and it will be due Monday.